We choose to go to the moon.
Since Kennedy promised to put man on the moon, no one's declared such an ambitious, humanity-defining goal in the realm of space. Well, that is, until Elon Musk. Musk, through his company SpaceX, is working towards the ultimate goal of colonising Mars.
Elon Musk has unveiled plans to turn the planet next door into a tourist attraction.
And we can be out there among the stars, making science fiction no longer fiction.
But while his rockets continue to dazzle us, there are some who think his plans just don't add up.
When does private enterprise lead us into space? I personally don't see that happening.
Last year, researchers published a paper that stated Musk's Mars strategy simply isn't feasible.
So how does he plan to get to Mars?
Why could NASA hold the keys to success?
And where does his dream even come from? To understand the situation today, first we need to go back. Before this. Before this.
Welcome to SpaceX.
Even before this.
Liftoff of the 25th Space Shuttle mission, and it has cleared the tower.
Back to a young boy in South Africa who dreamed big. In the 1980s, a teenage Elon Musk read the works of science fiction writer Isaac Asimov, his mind alive with possibilities.
The purpose of the Foundation is to save the sum total of human knowledge and to make it grow for the future after the darkness falls.
Stories of humanity establishing a colony on a distant world to ensure its own survival struck a chord. And decades later, Musk would tweet,
If we believe this Foundation myth, and for the moment why not, how do we get from childhood dream to what's increasingly becoming within Musk's grasp? The answer is those two old bedfellows, time and money.
In September 2000, a 29-year-old Musk was ousted as CEO from the company that would become PayPal. And with time on his hands and millions in the bank, he would return to his childhood dream. He searched the NASA website to read about their plans for going to Mars, figuring it had to be around the corner as the moon landings were decades ago. But he found only vague long-term goals. This instilled in him a belief that technological progress had to be fought for.
People are mistaken when they think that technology just automatically improves. It does not automatically improve. It only improves if a lot of people work very hard to make it better.
This idea merged with his reading of books like Foundation, and Musk came to believe that we must have an outpost on another planet for the sake of our own survival. And so, in 2002, Musk founded SpaceX with the ultimate goal of establishing a human colony on Mars.
Musk could hardly have picked a better time to start a rocket company, because America's space agency was floundering. NASA's Space Shuttle, its primary workhorse for the last 20 years, was beginning to show its age, and there was nothing in the wings to take its place. The Space Shuttle was a beautiful machine, but it had by no means been an unqualified success. It was supposed to lower the cost of travel to low Earth orbit. America's leading aerospace companies built the components. NASA paid them the cost, plus a profit margin, and brought all those elements together into a working spacecraft and operated it. To slash costs, it was partially reusable, so a new vehicle didn't have to be built from scratch for every mission. And it worked like this. You strap your shuttle to a big fuel tank with a couple of extra rockets. They help it all up towards orbit before dropping off when they've done their job, and then the shuttle goes and does its thing before finishing its mission and coming back to Earth to land like an aeroplane, ready to be strapped to another rocket and sent up again. The plan was that the Space Shuttle would launch 4 times a month, making space travel routine and affordable. We wouldn't just be visiting space anymore, we would be commuting there. But it didn't work like that. Problem was, to make this able to fly again, first you have to do this. It had to be stripped back to its component parts and then rebuilt to fly again. Now unfortunately the real shuttle wasn't made of Lego, so each launch cost something like $1 billion. The planned 4 flights a month became more like 4 flights a year, and the problems went far deeper than that. In January 1986, 73 seconds after liftoff, Space Shuttle Challenger exploded. An inquiry would conclude the no-ring, a kind of rubber seal in one of the solid rocket boosters, had leaked, turning the shuttle into a bomb. But this wasn't just a failure of a rubber seal, it was a symptom of a far deeper problem. NASA may have had total oversight over the private contractors, but this had created layers of bureaucracy, which watered down warnings from the engineers. Engineers at Thiokol had warned NASA that the O-rings could fail, and recommended delaying the launch. NASA managers under schedule pressure overrode their concerns. The loss of a second shuttle and its crew in 2003 forced a reckoning. It was too dangerous and too costly to continue for much longer. And after NASA's first attempt at a replacement was cancelled due to spiralling costs, the agency decided to pivot to the private sector and become not an operator, but a customer.
Now at this point, there wasn't really a private sector rocket industry that could build a whole rocket end to end. So NASA's plan was to try to jolt one into life using some of its own budget. And it was by doing this that they would turn SpaceX from a pipe dream into a rocket company. NASA would set broad goals for performance and safety, while private contractors would design, build and operate within them. Contracts would be fixed price and milestone based, and the contractor would only profit if it delivered on time and to budget. Then these NASA-approved rockets could be used by anyone who wants to hire one. Various suitors courted NASA with their designs and visions, and their field was, with a bit of legal action, whittled down to 2. One was Orbital Sciences, and the other, SpaceX. SpaceX hadn't even launched a rocket at this point, but it did have a few things going for it that made it attractive to NASA. First, it had strong engineering concepts. The designs were rigorous, and the roadmap for scalable launch systems ambitious but clear. Second, it had a viable financial plan. It was actively raising private capital so it would not be dependent on NASA money. And last but not least...
Say your name, spell it for me, tell me what you do. Elon Musk, Elon Musk, Chief Executive Officer of Space Exploration Technologies, or SpaceX.
It had Elon Musk. While Musk had no aerospace pedigree, he did have skin in the game, having committed $100 million of his own money into SpaceX. The guy was clearly serious, and NASA was impressed. But it was by no means a safe bet.
+1, +2, +3, +4.
In March 2006, SpaceX launched their first test rocket. It failed when a fuel leak started a fire. SpaceX's second launch reached stage separation, but the second stage tumbled due to a roll control problem. The third attempt saw both stages ignite before the second stage crashed with the first. And while each rapid disassembly gave them valuable lessons, they also cost money. By the time Flight 4 left the launch pad, Musk's company was on the verge of bankruptcy and its whole future was at stake. But this time,
stage separation.
The launch was a success.
Separation confirmed.
SpaceX became the first private company ever to put a rocket into orbit. And in the nick of time, NASA awarded it a contract worth $1.6 billion for 12 cargo flights to the International Space Station.
Musk himself would admit that this money utterly saved SpaceX, not only because of the cash injection, but because it helped convince investors and suppliers that SpaceX was a serious solvent player. And for the next decade or so, SpaceX would deliver on everything NASA wanted, while steadily becoming the world leader in rocketry. While meeting its NASA contract by launching regular cargo flights to the ISS, SpaceX harnessed that mantra of the tech industry that had given Musk his fortune: move fast and break things. As a private company not having to justify every nickel and dime to a stingy Congress, SpaceX continually pushed the boundaries of engineering, learning from every fiery mistake in a way NASA was never permitted to. And it yielded results, like the booster rockets that could be landed vertically and reused on future missions, lowering the costs. And after rigorous testing, SpaceX was entrusted with the task of carrying astronauts themselves to the ISS.
Today, we once again proudly launch American astronauts on American rockets, the best in the world, from right here on American soil.
Then they started reusing the crew capsules and standardizing their components to reduce costs. NASA's pivot to the private sector had been a success. SpaceX had given them cheaper access to orbit with rockets that were still made in America, while Musk had achieved at least part of his childhood dream. But don't go thinking this was a one-way street, because NASA gave SpaceX a lot of help. To give Musk's company a leg up, NASA shared half a century of engineering wisdom. It guided the development of things like life support systems, while SpaceX's docking procedures were built on NASA's decades of experience. It opened its doors to its facilities, like the Ames Research Center, used for every US space program since Mercury, where SpaceX tested the Dragon capsule and the Falcon 9 rocket. It leased some of its most iconic launch pads to SpaceX at bargain prices. And, perhaps most importantly, NASA's partnership gave SpaceX legitimacy, turning a startup into a trusted aerospace company that easily won contracts and attracted the best minds in the business. And Musk took all these things and used them to further his real end goal, a mission to Mars. SpaceX began engineering its most ambitious rocket system. Compared to its Falcon 9, it's twice as tall and about 10 times as powerful. It will become known as Starship. Musk forecasts a wide range of uses for Starship, from deploying large satellites to providing rapid transport between cities here on Earth. And NASA is investing in it too, with a variant under development that would ferry astronauts and cargo between lunar orbit and the moon's surface. But if you look back through the various names given to this launch vehicle during its development, you arrive at the original, the Mars Colonial Transporter. Its design may have evolved, but the ambition is the same. Starship is the rocket set to be pointed at the Red Planet.
I think it would be the best adventure one could possibly do, is to go and help build a new civilization on a new planet.
So Starship is designed to get to Mars, but how's that done? Well, it'll be a truly epic voyage. When Earth and Mars are aligned in such a way that the travel distance is at its shortest, a super heavy booster rocket lifts a crewed Starship into low Earth orbit. Tanker Starships launch separately, dock with the crewed Starship and transfer the fuel for the journey. Once fueled up, the crewed Starship performs a trans-Mars injection burn, leaving Earth's orbit to intercept Mars. That journey will take between 6 and 9 months, so the crew will need the means to survive. A closed-loop air and water recycling system, protection from solar and cosmic radiation, possibly a dedicated storm shelter. Once they arrive, the heat shield will slow the rocket down in the thin Martian atmosphere before it flips around for a propulsion landing. And then the real hard work begins, setting up life support systems, beginning to utilise Mars's natural resources to produce the fuel for the return trip. Around 500 days later, with the Earth-Mars window once again optimal and using the fuel created on Mars, the rocket will blast off and make the journey back to Earth.
This all makes NASA look quaint by comparison. It would appear that the student has overtaken the master. But is that really true? Well, maybe not.
In 2024, aerospace researchers in Germany published a paper that provides a thorough technical analysis of SpaceX's Mars mission, and to them, it doesn't look realistic. Really, it comes down to a couple of key issues. The first is weight. If you add up everything Starship needs to carry for a successful Mars mission, the radiation shielding, the structure, the heat shield, the solar arrays, the astronauts, the food, you get a figure that's more than Starship can feasibly carry. The second problem is technological readiness. So one example of that is the technology to produce fuel and oxygen on Mars, which you need because you can't take it with you. It's nowhere near ready, and what is available is too heavy, and we're apparently a decade away from solving that. The study also mentions the concept images created by SpaceX, which it argues bear little relation to reality, like the huge elevators which don't yet exist, but will be crucial and will need to operate in the midst of Martian dust storms. It concludes by stating that with the information currently available, a Mars mission with Starship is not feasible.
Now, say the problems were solved. There's an issue the study doesn't cover: cost. Now, Elon Musk is a wealthy man, a very wealthy man, but is he wealthy enough?
NASA has put the cost of a crewed mission to Mars in the order of $500 billion, while Musk has suggested up to $10 trillion to establish his long dreamed of colony.
So how is he going to pay for it?
Well, in 2024, SpaceX's revenue from launches was around $4.2 billion, though its profits were much smaller. Nowhere near enough. So Musk's most explicit funding stream is something else: Starlink. Starlink is a constellation of satellites that provides internet coverage to even the most remote of places.
If you look on your Starlink Wi-Fi router, you'll see this image, because the Starlink internet is what's being used to pay for humanity getting to Mars.
By 2023, it was generating more revenue than all of SpaceX's rocket launches combined, but profits are still low. And so there's another pillar to Musk's strategy to bring down the cost of Starship and launches. He wants to turn Starship into the Boeing 747 of space, mass producing them at a rate of 1 per day, bringing the costs down. And so just like the 747 did for package holidays, Starship would do for space travel, making orbital and interplanetary flights routine.
It's a tidy analogy, but perhaps not wholly connected with reality. But there is a more realistic route to Mars, which brings us right back to...
We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard.
In 1962, when Kennedy delivered his famous speech at Rice University, he fired the starting gun on a nationwide effort to innovate, engineer, and build the means not only to send astronauts to the moon, but also the technology to transport them to the surface, provide life support in a world without air, and of course, to get them safely back home again. The reason these huge challenges could even be contemplated was because the return on the whole enterprise was not profit, it was geopolitical, demonstrating superiority over the Soviet Union. And the returns had to be geopolitical, because there isn't a profit to be made on an investment that large, with a financial return that uncertain, or indeed non-existent. And the geopolitics are once again aligning like they did in the 60s. America looks to be heading into a second space race, this time with China, and with Mars as the finish line. The Trump administration has already laid down the gauntlet for America to win this race.
Launching American astronauts to plant the stars and stripes on the planet Mars.
Perhaps America's best chance of victory this time round lies in the combination of public and private sectors. NASA's decades of wisdom, experience and scientific know-how, paired with SpaceX rockets. So Musk may well get to Mars, but not without NASA.